Okay, to find the discounted payback period, we need the present value of cash flows. And because this is annuity method, because these are annual cash flows and there are 4 projects A, B, C, and D. For each project, we have to find the discounted payback period. So first we'll find the present value cash flows for project A. Present value cash flows is equals to annual cash flows into present value interest factor annuity Sorry for the disturbance. Hope I'm audible. So annual cash flows into present value interest factor annuity. Here, we forgot to give the interest rate. So you can write cost of capital is 12%. Rate is 12% for 8 years. You can see there project A. Here, project A, the annual cash flows are 1,20,000 and the life is 8 years. So we are going to see the annuity table for 8 years. Present value of cash flows is equal to annual cash flows, which is 1,20,000 into, we have to see the annuity table at 12% for 8 years. So let's go to the annuity table. This is a normal present value table. I have shared this table on the WhatsApp group. One of your classmates had asked me to do that, so I've done it. And for exams, when you come here, your exams are going to be offline. So tables will be provided in the exam hall from the department. Okay. So we need 12%. Let's go down to 12%. So we need 12% for 8th year. So 12% for 8th year, the value is 4.968. So we are going to take this value 4.968, which is 12% for 8th year, and find the present value of cash flow 4.968. So once we multiply, we get the present value cash flow. 1,20,000 into 4.968, 5,96,160 is what you get the present value of cash flows. Now we have to find discounted payback period. Okay, now I had taught you how to find the discounted payback period if they have given the series of cash flow. So in the previous sum, I hope you remember we had done it. So you see here, we see the initial investment. From that we minus the first year cash flow, we get the remaining balance. From that again we minus the second year cash flow, we get the balance. So here we had series of cash flow, but in this case that we are solving, we have annuity value 1,20,000 every year for 8 years, and we have the final answer, that is the total present value cash flow. So in this case, how do we find the discounted payback period? If annuity is given and we have to find the discounted payback period, we cannot use it doing that table. We need to apply a formula, or you can say a shortcut method. So what is that formula or shortcut method? We'll understand. What you have to simply do is you have to say this is for an annuity. So I'll write in the bracket if annuity is given, how to do it. Initial investment divided by present value of cash flow. you do this, you will get the discounted payback period. So discounted payback period is equals to initial investment for project A is 5 lakhs. So you do 5 lakh divided by 5,96,160. Just a second. Something's going. Just 1 minute. Discounted payback period will be equal to this. No, you do into 8 years. So 5 lakh divided by 5,96,160 into 8. If you do, you get 6.70 years. Means it's not going to take full 8 years. You're going to recover your money in 6 years, 6.70 years. So almost close to more than 6 years, 6.5, or even more than that. So this is how you can find discounted payback period if annual cash flows are given. Okay, then let's do for project B the similar way. First, we'll find the present value of cash flows, which is equal to annual cash flow into present value interest factor annuity for 12% and 7 years. So present value cash flows will be equal to, for project B, the cash flows are 1,50,000 every year. So annual cash flows 1,50,000 into present value interest factor. We should see 12% for 7 years. So we'll go to the table. 12% for 7 years, it is 4.564. So take this value into 4.564. Present value cash flows will be equal to 1,50,000 into 4.564. You'll get 6,84,600. Then we'll find the, here also change the formula. So the formula is discounted payback period is equal for an annuity is initial investment divided by present value cash flows into number of years. So we'll see discounted payback period is equal to present initial investment for project B. We'll check it is 6 lakh rupees. So 6 lakh divided by present value of cash flows, which is 6 lakh 84,600. 6 lakh 84,600 into will do the life of the project, which is 7 years. So discounted payback period is equal to check 6 lakh divided by 6 lakh 84,600 into 7, 6.13 years. It will take 6.13 years to recover your money back. Let's do it for project C. Similarly, we'll find present value of cash flow, which is equal to annual cash flows. So for project C, the annual cash flows are 1 lakh rupees. 1 lakh into present value interest factor annuity at 12% for 6 years. The project C has a life of 6 years. Present value cash flows is equal to 1 lakh into we need 12% for 6 years, which is 4.111. So we will take that value 4.111. Get the present value cash flows is equal to 1 lakh into 4.111. 4,11,100. Now we'll find the discounted payback period for an annuity, which is equal to initial investment. Initial investment for project C is 7,50,000 divided by the present value of cash flows 4,11,100 into life of the project, which is 6 years. Discounted payback period is equal to 7,50,000 divided by 4,11,100 into 6 years. It will take 10.94 years, which is more than the life of the project. So this kind of projects usually get rejected because the life is only 6 years and we want 10 years to recover our cash flows. Okay, which is not possible. So within the life of the project, it's not possible. Project D will do now. If project D annual cash flows is 2 lakh and life is 3 years, present value cash flow is equal to annual cash flow 2 lakh into present value interest factor annuity at 12% for 3 years. It's 3 years. Okay, so let's look at the table. We need 12% for 3 years, which is 2.402. So we'll take that annuity value 2.402. Present value cash flow is equal to 2 lakh into 2.402. Yeah. 2.402 it is. So present value cash flow is equal to 2 lakh into 2.402, 4,80,400. Now we'll find the discounted payback period. It's equal to initial investment divided by present value cash flows. Initial investment is 4,50,000 divided by present value of cash flows. We found out 4,80,400 into life of the project is 3 years. So discounted payback period is equal to 4,50,000 divided by 4,80,400 into 3. If I do, it's 2.81 years, which is nothing but close to 3 years. So these were the discounted payback periods for each project. They have asked us to rank the projects as per the discounted payback period. So we have 4 projects right here. Projects, discounted payback period, and rank. Project A, B, C, and D. The values for project B it is 2.81 years. Project C 10.94 years. 6.13 years for project B. And the project A is 6.70 years. Okay, now how are we going to rank it? Not on the highest value, but on the lowest value, because we are not seeing the amount here, but we are seeing the time. And when you see the time, what is important is how early we can recover our money. So 2.81 years will get the first rank because within 3 years you can recover your money entirely. 6.13 years will get the second rank. So from the lowest you have to start ranking in case of payback periods, because it is period and lesser the period, faster you will receive your money. In project C, at least you can give it fourth rank, but this has to get rejected because the life of the project only was 6 years or 7 years, and then the recovery is 10.94 years. So you cannot accept this project itself. So if any company wants to start using discounted payback period, project D should be started first, and then project B, and then A if they want to invest in more than one project. So this was about discounted payback period if annuity is given, and how to do it when the normal series of cash flow is given. I've already taught you in my previous class. So today let us start with the last discounting technique, that is modified internal rate of return. I had first started with NPV, then we did IRR, then we did profitability index and discounted payback period. This is the fifth discounting technique, that is modified internal rate of return. After this, we will start with our non-discounting techniques. There are two non-discounting techniques, accounting rate of return and payback period. What I taught you now was discounted payback period, and there we'll only have a simple payback period. So let us start with the modified internal rate of return. Now, how is it different from the internal rate of return? In case of internal rate of return, we usually did trial and error method to find that particular rate. But in case of modified internal rate of return, we don't use the trial and error method. There will be a rate already given. Using this, we have to find IRR. So there is no multiple times you need to sit calculating at 10%, then assume 15% or 5% and do it. No, here they'll give you the rate and there's a formula. Using that formula, we need to find the rate of return, internal rate of return. So we also call it as modified internal rate of return. Okay, I'll first give you the formula for modified internal rate of return, and then we will solve it one by one. Okay, so the formula is PVC is equal to PV divided by 1 plus MIRR 1 plus MIRR raised to n. This has to go raised to. So now what are all these values? PVC is equal to this present value of cash outflow. So whatever initial investment we are doing, that is PVC, that is finding the present value of that. What is TV? TV is nothing but terminal value, and MIRR you already know, it is modified internal rate of return. And N is nothing but the life of the project. Okay, so this is the formula. If you see in the formula here, there is no MIRR. It is there after the equal to sign. So we need to solve it and find MIRR. Other things we'll find first and then the MIRR. So everything will not be given here. We need to start finding one by one. So first we'll find PVC. As I told you, PVC is nothing but present value of the cost or the cash flow. So here you can see there is minus sign for 120 and 80. These two are the cost or the initial investment. We need to find the present value of these two. So how are we going to do it? 120 into present value interest factor at 15% they have told. I'm not seeing the annuity, I'm seeing the normal for 0 years because 120 we are investing in year 0. If you could just see here, 120 is invested in year 0. Then the next is 80, so plus 2 times we are investing. So plus 80 into present value interest factor for 15% for 1 year. Okay, so this is how we need to calculate PVC. We are finding the present value of cost. We can do it in the table also, like we did above for above problems. Whenever we found the present value, we basically did it in the table like this. But then it is only for 2 years. Making a separate table for 2 years, better than that, we do it using the equation. So present value of cost is equals to 120 into present value interest factor at 15% for 0 years. Now in this table there is no 0 years, but in the table that college will provide you, there is also a 0 year. For 0 year, all the values will be equal to 1. Okay, because year 0 is already in present. So present value interest factor at 15% for 0 years is equal to 1. Plus we have to see 80 into present value interest factor at 15% for 1 year. So we'll go to the normal table. This was the annuity table. This is the normal present value table. At 15%, we need 1 year value, which is 0.870. So we'll take it 0.870. Present value of cost is equal to 120 plus 80 into 0.870, 69.6. So present value of cost will be equal to 189.6. This is the first thing of the problem that we have got. Any doubts in this, please ask. Otherwise, we'll go to find the other things, that is the terminal value. We have found out the PVC now. Next is to find the terminal value. Is there any doubts, anybody? Next is the terminal value. Now the word itself tells you that you need to terminate or end or reach to the uh, last or complete the life of the project. So terminal means terminate, close it. The project will be closed when we reach to the last year of the project. So we need to find the terminal value, for which we need not come back to present value. If I have to find the terminal value, I'll not get 20 back to 0, 80, 60 back to 0. Instead, I'll go forward. Last year, I'll take 20 to the 6th year, 60 to the 6th year, 80 to the 6th year, and 100 to the 6th year. So I'm going forward means I have to use the future value table. I told you initially only that MIRR is a different method altogether to solve. So here we are going to calculate the future value of all these years to find the terminal value. So let us take solve for it. Terminal value in the year, cash inflow, future value interest factor at 12%, given, sorry, 15% rate is given at 15%, and we'll write here future value. Okay, so we need these 4 columns. First 0 and 1 year were investment. From second year we have the cash inflows. So 2 to 6 years we take here. The cash inflows were 20, 60, 80, 100 and 120. So we are going to see the present value interest factor at, sorry, future value interest factor at 15%. Let me see in this table. Do we have future value? Just about the present value. I'll tell you the future values. You can note it down here. I'll see the next. I'll download another table which has future value also. So future value interest factor at 15%. Now, important thing is for how many years we are going to see. Okay, we are not going to see it for 2 years here. We are going to see for how many years we are going into the future. So see here from 2 to 3, 3 to 4, 4 to 5, 5 to 6. How many years? 1, 2, 3, 4 years we are going in the future. Okay, let me just see here. 2 to 3 is 1 year. 3 to 4 is another year. We are going in the future. Okay. Then 4 to 5 and 5 to 6. So 4 years we are going into the future. I'm trying to show it through the brackets here if you are able to observe it. Is it visible clearly to everybody? So 2 to 3, 3 to 4, 4 to 5, 5 to 6. 4 years ahead we are going. So we need to find future value interest factor at 15% for 4 years. Okay, so how much we will get? If I find it for 4 years, looking at the table, I'll get it as 1.749. 749. Okay, in the next class, I will give you the table and show you how to find the future value. it is similar like present value. You just need to go to 15% and see the fourth year, but still I will show you once. Okay. So this is how we have to calculate the future value interest factor. Let's do it for the next year. First we'll multiply and find it here. So if you do 20 into 1.749, we get 34.98. Similarly, we'll find future value interest factor at 15% for now how many years? 3 years. We're going to get it down here for 3 years. I'll just show you. Now we are in third year. So third year to fourth year, then fourth year to fifth year, and fifth year to sixth year. So only 3 years now. So we are going to get it for 3 years. Okay, for 3 years the value is 1.5 to 1. And if you multiply 60 into 1.5 to 1, you get 91.26. Similarly, we'll do future value interest factor at 15% for 2 years now. I'll show you how 2 years. You can see this from fourth year to fifth year and from fifth year to sixth year. There are only 2 years. So fourth to fifth and fifth to sixth are the 2 years that we are going to use. And the value for the 2 years is 1.322. And if you do 80 into 1.322, you get 105.76. So we are finding the future values. You can see they are more than the present value. 20 rupees has become 34.98, 60 has become 91.26, and so on and so forth. Future value interest factor at 15% for 1 year now, because we are in the fifth year. So 5 to 6, there's only 1 year that is left. So we'll do it only for 1 year from 5 to 6, and the value is 1.150. Multiply 100 into 1.150, you will get 150. The last one, future value interest factor at 15% for 0 years now. Why 0 years? Because there is nothing left. We are already in 6th year. We need not go from 6 to 7. So we are already in future. That is end of the 6th year. So 0 years. Okay. So 15% at 0 years is equal to 1. Anything at 0 years will be equal to 1. So 120 into 1 is 1. Now we'll find the total of the future value. That is nothing but our terminal value. So if I add all this, 34.98, 91.26 and all that, we'll get 467. So now we'll take a formula. We have present value of cost or cash flows, and we have the terminal value. We can now put these values in the formula and find the MIRR. So present value of cost 189.6, which is equal to the terminal value 467 divided by 1 plus MIRR raised to n. Okay. Now we'll go to the next. Okay, so what I'll do is I'll get this 1 plus MIRR this side and take 189.6 that side. So cross multiplication, 1 plus MIRR raised to n is equal to 467 divided by 189.6. So you get 2.463. So 1 plus MIRR is equal to 2.463 if you divide. Okay, and here N we know the life of the project is 6 years. So we have to, instead of N, we have to take 6 years here every time. Okay, now what I'll do is this raised to 6, I'll get it on the other side. If I take that raised to 6 on the other side, its reciprocal will change and we will have 1 plus MIRR is equals to 2.463 raised to 1 by 6. 6 raised to 6 when you get on the other side, its reciprocal will change and it will become 1 by 6. That is 1 divided by 6. This is again the raised to value. Okay, now solving for this, you need a scientific calculator. So 1 plus MIRR is equal to, you have to use the scientific calculator and see 2.463. For raised to, there is a cap sign in the scientific calculator, so you need to use that sign. Okay, it's like, I hope you're able to see this sign. I'll increase the font. You cannot solve these sums without the scientific calculator, so it is important.
0.415.
How much you get?
0.4105.
No, you should get 1.162. What mistake you might have done is you take that 1 by 6 into the bracket. First you need to divide and then multiply it with the raised to. I hope you're getting it.
Yes, ma'am.
So this 2.463 raised to that cone type or the triangle type shape, and then you open a bracket and write 1 divided by 6 and close the bracket. You get 1.162. Are you getting it? All those who
Yes,
have
ma'am.
scientific calci will be able to get it. Okay, so now MIRR is equals to that 1 plus MIRR, 1 we will get it this side, so it will be 1.162 minus 1. It is 1 plus, if I get it this side, it will become minus 1. So MIRR is equals to 0.162. If I multiply it with 100, it is equal to 16.2%. So we are not doing trial and error like IRR, but we are using a formula and finding the MIRR. For MIRR, they will give you the cost of capital. Using that, you have to find the present value of cost and future value of cash inflows, that is PVC and TV. Once you get those, you have to insert the values in the formula and find the missing term, that is MIR. Anybody having any doubts, please ask. Others will do the next sum on MIR. Is that clear, everybody?
Yes, ma'am.
Let's do another sum then. From the following cash flows, calculate MIRR. They've given you year and cash flows. And here you can see the investment is only in year 0. There is no year 1 which has investment. So this is a formula for MIRR. Just note it down. Okay. So first we find the PVC. PVC is nothing but present value of cost and or initial investment. So your initial investment is 1 lakh into present value interest factor at 12%. They've told it is 12% for year 0. So anything for year 0, I told you, is equal to 1 if you look at the table. So it is 1 lakh into 1, which is equal to 1 lakh. So present value of cost is 1 lakh itself because we have investment only in year 0. In the previous problem, we had investment in year 0 and 1. So we had to find the present value for that year 1. and we got a different answer. For year 0, the present value interest factor table value itself will be equal to 1. So anything multiplied by 1 will be the same. Now we have to find the terminal value, which is nothing but the future value for the cash inflows. So terminal value, find the future value. Year, one more column, cash flows, future value interest factor at 12%. They've given the rate as 12% and the future value. Okay, so for years it's from 1 to 5. Cash flows 20, 30, 40. So I'll just copy them here. Okay, let's find the future value interest factor at 12%. So here we have to see for how many years. Okay, I'll just put those brackets again. Future value interest factor at 12% for, let's see how many years. I have to go to the future. So from 1 to 2, 1 year. Then from 2 to 3, second year. 3 to 4, third year. And then you have 4 to 5, fourth year. So totally 4 years we are going in future. So we have to find the future value for 4 years. Okay. So I'll do here for 4 years. The table value that I got is 1.57. Okay, similar way we will find future value interest factor at 12%. Now it will be for 3 years. Okay, that is from 2 to 3, 3 to 4, and 4 to 5. 2 to 3, 3 to 4, and 4 to 5. 3 years only. Okay, so 3 years, the value is equal to 1.405. What values I'm writing are the table values. I will download the future value table and send you, and I'll show you in the next class how we are seeing. It is similar like the present value table. There's nothing new that is there in it. Only instead of present value, you need to go to the future value and see 12% for 2 years. Okay, now 2 years because we are going from 3 to 4 and 4 to 5. We are in third year, so from 3 to 4 and 4 to 5. Future we are going. So for 2 years, the table value is 1.254. Future value interest factor at 12% for 1 year, because we are in the fourth year, which is going to go from 4 to 5 in future. Okay. And the value is 1.120. Last one, future value interest factor at 12% for 0 years. And for 0 years, it is always equal to 1. Okay, so we'll now multiply 20,000 into 1.57. We'll get 31,480. 30,000 into 1.405, you get 42,150. Then 50,160. 56,000 and 35. You add all this, you get 2,09,790. This is a terminal value. Now we can put the formula of MIRR and calculate MIRR. Okay, so PVC is 1 lakh equal to terminal value is 2 lakh 9,790 divided by 1 plus MIRR raised to n. N is 5s.
Excuse me, ma'am.
Yes, tell me.
Ma'am, that is that 1.57 into 20,000. I guess it will be 31,400.
Yes, ma'am.
31,400.
It's
Okay,
31,400.
Yes, ma'am.
31,400. Just check the total then. Plus
2 lakh
42,150.
9,710.
710.
Yes, ma'am.
Yes, 2,09,710. Okay, so what we will do, we'll take this 1 plus MIRR that side and get that 1 lakh here. So cross multiplication. Okay, so I'll write here 1 plus MIRR raised to 5, which is equal to 2 lakh 9,710 divided by 1 lakh. Once you divide, just check how much you get after you divide. 2,09,710 divided by 1 lakh.
2.097.
2.097. 971 exactly I'm getting, so I'll take those. Okay, now that raised to 5, we have to get it on the other side. So it will become raised to 1 by 5. So 1 plus MIRR will be equal to 2.0971 raised to 1 divided by 5. So raised to, in your calci, you have to use that cone sign for raised to or the triangle sign. Okay, so 1 plus MIRR is equal to 2.0971 raised to, open the bracket and do 1 divided by 5, close the bracket, 1.1596. You're getting 1.1596. All of you getting it? All those who are trying?
Yes, ma'am.
So MIRR will be equal to 1.1596 minus 1. That plus 1 I brought to this side. So MIRR is equal to 0.1596. If you multiply it with 100, is equal to 15.96%. So this is how you have to find MIRR. These were all the discounting techniques. In the next class, I'll start with the non-discounting techniques. Okay. So you can, if you have any doubts, you can ask. Otherwise, you can type your roll numbers and leave them.